the CEO and founder of this company called Unlock Protocol, and I'm animating the panel on micropayments. I'll maybe start with letting everyone introduce themselves, and we'll get started after this. So, Chris, want to get started?
Yes, I do. Hi, everybody. So I guess we're introducing ourselves and the company as well?
Yeah, I think better.
Okay, so I'm not in Micropayments, so I'm not This is actually goes into my soapbox moment about layer 2. This is such a broad description of things that we all do. It's like, are you not layer 1? Okay, you're layer 2. So that's what do we actually do? So my name is Chris. I am the CEO and co-founder of Alacrus. What we do is we're tackling the developer onboarding problem. Now, there's 30 million developers in the world, right? And probably around 20,000 blockchain developers. That's a huge problem. I'm sure all of you that are actually working on protocols are going to actually run into the problem of getting developers on your platform. We had the same problem. We originally built a scaling solution, decentralized scaling solution, and we discovered that really nobody gives a shit about scaling. They care more about using the platform. And the problem is that talk to quite a few developers, both blockchain and regular developers, and that they just didn't want to come into the space. So we started doing research and finding out why. Number one, it's just way too damn hard. Like right now, it needs the equivalent of 5 different PhDs to be able to build a successful DApp right now. And that's not an exaggeration. Like you need really, really smart people to build a successful DApp. That's not scalable. That's not going to bring in the 30 million developers. Second, how do you know which protocols to choose? What base layer to choose? Which, I mean, we just saw it's 6 people up here that have different layer 2 scaling solutions. Which one do you choose? You shouldn't. And 3 is that even if like these teams that had millions of dollars that hired those dream teams and without experience, those very teams are losing hundreds of millions of dollars because of smart contract mistakes. Why would any centralized developer ever want to come into the space? The truth is they don't, and they won't. And I know this because I asked them. So what we did is we said, okay, well, if we want people to use our scaling solution, we need to actually attract those 30 million developers. And if we don't, or if somebody isn't, blockchain fails. And that's the truth of it. We need developers in the space. So what we do is we're built a development platform that provides a DSL that abstracts the application of blockchain away from your traditional developers. So they can focus on building features rather than actually building the low-level functionality. Second, we built our platform is blockchain and protocol agnostic. So that it's a write once, they choose which protocols they want to launch, which scaling solution they want, and can change their mind later and not have to rewrite it. So like write once, use anywhere. And then finally, I don't know how many people out here, actually question, how many people out here actually know what formal verification is? Okay, so for the people that don't, it's math magic. What it is it simulates all potential realities to prove that the code itself doesn't have any bugs. That's awesome. It's been around for a long time. Why isn't it used everywhere? Because it's really hard to find people that have the skill set to do it, and it extends the actual runway by about 10x. Well, we figured out actually how to do it automatically. So a developer that has never done formal verification before can come onto our platform, write their application in our language, and through the compilation process, automatically formally verify the entire decentralized application. Not just the smart contract, the entire thing. Side chains, state channels, client application, the entire thing, and from a single spec. So that's what we believe that it's going to take to actually make blockchain succeed, and that's what we do at Alacrus.
Great. Next we have Michael, who's working with Southern Network.
Hi everyone, I'm Michael from Southern Network. So what we are is we're a combination of a payment channel solution and a general state channel solution. And we tried our app ever. It was a chess game where like 2 parties play against each other, and all of these like happen off-chain. Like Alice opens a channel with our payment hub, and Ross opens a channel with our payment hub. They can just exchange the states off-chain, and then like Alice was sent a conditional payment, which I guess that's like the aspect of like where we are in the micropayment business. So Alice will send a micropayment based on the condition that Alice wins the game, and Bob will send another micropayment based on the condition that Bob wins the game. And once the game is like finalized, like either Alice or Bob will actually send the payments. And if say like Bob wants to bail, or like basically wants to cheat, Alice can dispute, and then we just we deploy the smart contract, and then it switches, it like degenerates into a traditional DL, and then the payment will still go through based on the this on-chain condition that Alice, either Alice or Bob wants to do. Yeah, that's what we're like a combination of payment channels and state channels, and we support both value transfer and like logic, general like transfer bits or any off-chain state channels.
Great. Next we have Arjun with Connext.
Hi, I'm Arjun from Connext. We're a state channel network on top of Ethereum. We're live and have like been used in production with Spangchain, Ujo, Civil, a bunch of other companies that are doing micropayments right now with like end users. That's pretty much it. Yeah.
Cool. And then finally, we've got Yondan from Live
Hey everyone, so my name is Yondan, I'm a software engineer at LivePeer. LivePeer is a public video streaming infrastructure project. What exactly does that mean? So any video developer today that's building an application that wants to stream video to a wide audience, whether that be on demand or live, needs a lot of different components that at an infrastructure level, including distribution, so that is usually accessed via a content delivery network. And then also another really important piece is transcoding. Transcoding is this process by which a single piece of content in a single input stream gets translated into all these different other versions of that same stream, so that regardless of what internet connection speed you have, whatever size device that you have, you can watch some quality of that content that someone is broadcasting. So it helps you reach the widest possible audience. That process is pretty expensive today for application developers, unless you're a Google or a Facebook and you have an in-house team that builds out the infrastructure for you. But if you're a startup, usually what you'll do is you'll outsource this computation to a third-party service provider, and there's a select number of big ones. You might have heard of Amazon. They're a big player in the space, and it can get pretty expensive though. So you either pay a lot of licensing fees to license proprietary media servers from them that you deploy yourself onto your own servers, but you have to pay on a per license basis. Or you can pay as you go, but the pay as you go model is pretty expensive as well, and it can be something like $3 per stream per hour. And you can imagine a service like Twitch that is streaming at scale that has maybe hundreds of thousands of concurrent streams per hour. This adds up pretty quickly over the course of the day. So what we're building is, as a first step, the transcoding component. So a marketplace of incentivized nodes that transcode video on behalf of the end user. And one particular audience that we're trying to tap into are actually cryptocurrency miners, because cryptocurrency miners represent hardware that's already deployed around the world, and the cost for that hardware has already been paid for, but the GPU mining rates that they have actually can be quite efficient for video transcoding as well. And where micropayments come into the scene for us is that we'd like to present metered computation, so metered transcoding, such that individual broadcaster can pay on a pay-as-you-go basis on a really granular and continuous basis for video streaming.
Yeah, so before we go too far into what are the implementation that each of you do around micropayments, I guess everybody's familiar with the idea of micropayments, right? Does anybody know or doesn't know what micropayments is? Cool. I guess the context of micropayments on that panel is really that doing micropayments on chain is probably at this point impossible for a bunch of reasons. Obviously, one of them is throughput. We say micropayments saves pretty many transactions, and given the state of blockchain at this point, this is not possible. And it also, given the state of blockchain, saves fees that might be actually higher than the micropayment itself. So I guess that's why we're talking about micropayments tonight, if that makes sense. Maybe why don't you started in London, but describe why or how you think about implementing, or what you're thinking about implementing when you talk about micropayments in your applications and protocols.
Sure. So I think micropayments for us, we kind of think about it on two fronts. So there is the mechanism and protocol by which that you implement the micropayments, but then another component is the accounting and fair exchange portion. So how you can actually, once you have a micropayment mechanism, how do you do fair exchange of a micropayment for amount of service? So the first part, I won't get into too many of the technical details unless people are interested in. Our first implementation is a probabilistic micropayment implementation. So it is at a high level based upon this notion of paying people with lottery tickets. And this might seem strange at first due to the probabilistic payout nature of a lottery ticket, but for this particular use case, for a very granular continuous payment stream that is represented by a video stream, we really don't care as much about how much someone is making on like a per second basis, but we really care about how much someone is making on like a multiple stream basis over the course of many hours. So the idea is that while you might not be paid a certain amount within a matter of like a couple seconds, due to the law of large numbers over the course of many streams over many hours, you'll be paid fairly. And the idea is that all these interactions happen off-chain, so that you don't actually have to go on-chain for any of these payouts until a lottery ticket pays out for you. There's more to talk about there. And on the other side of things, we can talk a little more about this later, but yeah, fair exchange is a tough problem to solve in micropayment context, especially when you're dealing with services. I think when you're just doing a swap between two assets, you know the exact value of the other asset, so you can do that swap. But when you are dealing with like meter computation and you're sending in an input to a service provider that needs to perform some service on that input, they don't necessarily know what the cost of actually processing that input is, and the cost of processing that input could far exceed the amount of the micropayment that you're actually sending. So that's another.
Yeah. So to sum up, basically, you're doing micropayments, discrete micropayments, where basically you're using the fact that these lottery tickets, some of them are willing to pay for the large number of actual transactions that somebody might have done once every couple of thousand extra transactions. That makes sense?
Yeah. The one additional detail I'd add is this obviously presents user experience challenges, but I think one of the main reasons why we think that these can be abstracted away from the end user is that we're really talking about like machine-to-machine automated agent payments here, where there's very little user interaction on like a per second basis. Once again, there isn't going to be someone monitoring a UI constantly, but it's going to be more like I configure my preferences for my node, and then based upon my preferences, they will automate the payments that I make over the course of like a week.
Sure. So Arjun, in your case, you're actually not doing machine to machine, it's actually people to people, and this time you're using state channels. Why don't you explain how that actually works?
Yeah, so this is probably something that was like roughly covered in the first panel, but we have a relatively simple system that's just a hub and spoke network. The goal is to upgrade that later, but we prioritize usability and actually putting like this in the hands of like production users faster than being having the full network built out from day one. That actually turned out to be a very good decision because we ended up rebuilding the system like 3 times because we found a bunch of things that users do that like you don't expect. They don't care about a lot of the things that you think that they care about. And so on like the way that our current implementation works is you deposit into a channel with a hub. You then send a transaction to anybody else who's connected to the hub, and that happens completely off-chain. That doesn't happen using like Lightning Ring style HTLCs. We use a dispute-based paradigm that's very, very similar to how counterfactual works. And the rationale behind this is just that it dramatically reduces computation costs on a per transaction basis. So it lowers like the minimum bound of like payments that you want to do to the point where like the cost of doing a payment is effectively the cost of just like bandwidth, which is pretty awesome. The smallest things that we do right now are with Ujo, where they do like when you listen to a song on Ujo, you pay like fractions of a cent every 15 seconds. As you listen to the song, which are automatically paid out to the artist and then anybody else that they select in the stable.
So that means that the user has to first stake or put some funds in the channel, and then basically that amount of money will slowly be spent basically just do that example.
Yeah, so one thing that I think a lot of people don't realize is that channels are just like wallets. Right, a channel is just an independent multisig. And so you should treat it like a contract wallet. For now, while we're talking about like discrete systems where like this person has a hub, this person has a hub, this person has a hub, or like a bunch of different channels that aren't really connected to each other, it's effectively the same as like you having a bunch of different wallets, one on like each application. And that sort of makes sense for now because you're not trying to build this like giant interoperable system. There's like the users that are using Spank Chain are probably slightly different than the users that are using Ujo and like other applications. But the eventual goal is that your entire, like everything, like a channel is a superset of what you can do with a wallet. So eventually you just put in all of your assets into the channel and just use that as your wallet.
Okay, great. Michael, you guys also do micropayments. As you said, you started chess game. Why don't you explain how exactly that works?
Yeah, so it's kind of similar idea to what Nexus to me. And basically, like Alice opens a channel or like a multi-sig with, it could be, so in our case, it could be multi-home. So it doesn't have to be like single hub. It can be just like some, we call this like off-chain service provider. And so Alice opens a channel with the service provider and Blob does the same. But it could be another service provider, in which case like the two service providers can have another channel like between them. And so like when Alice starts a game, a chess game with Blob, she will just send a conditional payment. She'll basically say, I'm going to pay Bob like 5 Wei in terms of micropayment, 5 Wei if I win this game. And like correspondingly, like Bob will say, I'm going to pay Alice 5 Wei if I win this game. And this game is like this condition is like can be codified in like a smart contract. And the smart contract is first like executed off-chain. And like you can use another implementation if you want, because basically like, the two parties just have to agree that on the split that like I win this game or like he wins this game. And so once that condition is satisfied, like Alice will say, okay, confirm payments, and then Bob will say, I reject the other. Like you don't have to pay me. Like I'm gonna confirm my payment, and you don't have to pay. Like, you don't have to confirm your payments. Like, that's how it works. And in terms of disputes where like Bob runs away, say, I'm gonna lose this game. Like I don't want to pay anymore, I just want it back. And Alice will just deploy the contract on-chain, and then like the on-chain state channel contract will be able to tell, okay, like Bob, Bell, and like Alice is the sole winner, like the sole submitter of this data proof, and Alice will be granted, and Bob will like, use that.
So this is micropayments because it's a small amount, but there's still one single settlement.
Well, you can like once Alice or Bob like, opens the channel with the service provider, they can pay like hundreds of games without any like on-chain. Like basically, there was only ever 2 on-chain transactions. The first one is like when Alice opens the channel. The second one is either like when Alice is so good at the game, like Alice is so bad at the game, and she has to like, constantly deposit money to like deposit just to like to refill the wallet. And or like when say like Bob cashes out, you have to like close the check. I mean, you just have to close the check. You can, like withdraw money, like deposit money.
That makes sense. Chris, so obviously you guys have a different perspective on micropayments. You don't do micropayments. But the sidechain thing is interesting. Like, could, in the context of what we described earlier, somebody use a sidechain to actually do micropayments, assuming lower transaction fees and higher transaction throughputs?
So let me talk about this a little bit. So we actually do have a scaling micropayment solution. That being said, there is no one size fits all. Every one of these solutions up here is a great solution. But so what we do is we actually, like our goal is to actually have a partnership with all of these solutions. So that when a developer comes in, so that they don't have to say, okay, well I need this type of way, so I have to learn this platform. They come into our platform. They decide what type of scaling solution they want based off the features that it provides. Use our platform to abstract away those differences, so that they can choose or maybe one, if maybe not two. That being said, we also do have a scaling solution. You mentioned the sidechain. So one of the first primitives that we built is a sidechain that's similar to Plasma, but it uses a data availability network to prevent against block voting attacks. We're going to be launching that in the next couple of weeks, which is pretty exciting. But the thing that will come after that is side chains are exciting, state channels are exciting. But when side chains can generate state channels, we're getting really excited. Now we can talk about micropayments that can, like, number one, are very fast to generate, very fast to actually shut down, and you can generate tons of them. So at that point, it's like, okay, I know that I'm going to be spending $1 in the next minute with you. So let's generate a state channel on top of a side chain very quickly, and then keep going very fast. And it solves a lot of problems with rebalancing and a lot of the problems actually like routing that state channels have. So that's kind of like what our view is on that. But once again, there is no one-size-fits-all micropayment scaling solution. It's give all the options possible and allow the actual developers to actually implement them with one code base.
Great. Arjun, question for you. A couple of years ago, Nick Szabo wrote a white paper, I think, on the theme that micropayments were actually not a viable solution, not so much because of the price, but because of the cognitive load that it triggered for users. Like whether it's not so much that paying 5 cents is expensive, it's like making the decision of paying 5 cents is expensive. Is that something that you guys are encountering in the application that you're building, and how are you doing that?
We're like, so I'm trying to think about the best way to this. First of all, empirically that is incorrect. Because WeChat exists and people do micropayments through WeChat all the time, and it's like billions of dollars in value. Secondly, the goal is like this is more of this sort of ends up being more of a cultural thing, where like it's sort of how people are wired to make payments on the internet. Right now, making payments on the internet is a really difficult task and does require a lot of cognitive load. But we do see that there is like a really strong interest in being able to support people directly, like financially through the internet as well. And this is not just coming from like creators on the internet or people who want to monetize things, but also from users of like power users of things. So I think it's more of like this is infrastructure that can be used in a lot of different ways, and nobody quite yet knows exactly what the models will be. But there is an existing precedence of these models working, and the flexibility of the infrastructure itself is what lends itself to a diverse array of business models being created.
In terms of UI, like how does that work? As a user, I top up my Ujo account and I see kind of the money going away as the song makes progress, and I'm incentivized to click on the next one halfway through this because I don't want to spend too much money on that one. How is that working?
Yeah, I mean that's basically it. Like Ujo's just running experiments with it right now. It's sort of like interesting to see how different things work for different users. Yeah, that's basically it. Like your Ujo account is still the same account as your like account and your like account for other things that are connected to the same hub. So you can top it up once and then also go support a bunch of podcasts or like pay for other crypto content. There's like some people that are trying to implement micro paywalls on articles and like newsletters. So that sort of stuff would all just fall into the same category. Like I put $10 in my account and I use it to support the things that I care about.
Great. Yondan, you guys are doing micropayments between machines, so not between people. What are the challenges that you're actually seeing in that world?
Yeah, I mean, I think it's a different environment, right? I think one of the benefits of the machine-to-machine environment is that you don't have cognitive load. Like people aren't making these active decisions. But some of the other challenges involved with that is that unlike when you're doing person-to-person payments where the person is actually signing each particular transaction, whether that be an off-chain message or an on-chain transaction, the user is actually actively signing and authorizing actions each time they make a payment. But in the machine-to-machine context, most cases you're letting a software program take control of a hotkey and then using that hotkey to sign on your behalf in order to sign payments. In the best case scenario, everything is implemented perfectly and you don't have that much of an issue in terms of like implementation bugs. But obviously, software has bugs, so it's quite possible that if you have a bug where you sign payments that you're not supposed to sign, then you end up overpaying someone or you end up draining your deposit on chain or something like that. And then there's also key management. So even if the implementation is perfect and you don't have any bugs in the software, this is a potential honeypot for people because one of the best user experiences is I can top up my deposit once and I have a lot of funds in this deposit, and I don't have to worry about topping it off for a while, but that also means that anyone that's able to gain access to the correct keys could potentially also drain your deposit. So I think those are some of the challenges security-wise with machine-to-machine payments. So I think one of the interesting areas of exploration, and actually one of the most crucial areas of exploration on that front, not only for us, but for any type of project that's doing machine-to-machine payments, is key security and figuring out the right approach to key security so that people that are running these nodes have access to secure methods of actually running these nodes.
Great. I think we've got 5 minutes left, so I want to open questions to the audience. Is there anyone that has remarks, questions, interrogations on micropayments?
Yeah, so when you talk about these like side channels staying open for these microtransactions, like what's the time scale, or is that just it depends on the application? You talk about things like happening like multiple times a second or something, or is it something like if I go to Starbucks every day and get a cup of coffee, can that stay off on the side chain?
This goes to the not one size fits all. Sometimes you want state channels open for a long time. Sometimes you want them to be open and shut quickly. And that's kind of what I was talking about with state channels on top of side chains. When you don't have the latency of the base layer itself, you can actually stand up and shut down state channels very quickly. That's my thoughts.
So the end goal of like a state channel network is to be able to put all of your money into one channel and then use that to pay anybody, right? Or to conditionally do anything using that same balance. If that's the case, then you don't ever really need to close your channel. Our system is designed in a way where the concept of closing and opening channels doesn't even exist. Your channel is keyed by your address, and you can deposit and withdraw, and you partial deposit, partial withdraw, and that just means it's exactly like a wallet.
What if the other party tries to brief you by not responding, and then the channel is blocked for a week or whatever?
You can still do a unilateral withdrawal.
Yeah, you can do unilateral as well. So basically, one of the requirements in the protocol is that you're correct that both parties have to be online. So if you ever goes, if one ever goes offline, in principle, the person is already violating the protocol. So the other party can not only just withdraw from the party's deposit.
It takes 1 week, so for 1 week all funds are blocked.
You can set the dispute time.
It's not.
Yes, and then it becomes insecure for the other party.
I mean, not necessarily, right? We have ours set to a day, and
Day is.
yeah. I mean, we're sort of assuming that there's information availability, which I think eventually you can make that assumption once a watchtower network exists. But it's more I don't know. It's more it doesn't even need to lock down operations, right? You can do fast exits where in an exit you only need consensus from 2 people. So it's either both people agree with the exit or they don't. And if they don't agree with the exit, there's a pessimistic situation in there too, where it's if you submit a state and then the other person submits a state, and then those states match, then you can just have the dispute be closed faster anyway.
Sure, but if the person just wants to brief you, if they can work you for a day, a week, or whatever, and then all your money is cut for a day.
The process is hard for, you're talking about a briefing attack where the counterparty just deliberately not respond to you, or is it?
No, or doesn't respond for a week or
Yeah,
for a week.
or the person has to pay the
Whatever
penalty.
the penalty is.
The person has to pay the penalty. The person
Well, just before the deadline, they put their update.
Sure. So what would happen if you were using an ISP and then they shut off your internet for a week? You just stop using them, right? It's this is sort of an open market of nodes where the real trust problems exist with nodes that are not the ones that you're connected to necessarily. They're the ones that you're routing over to get your final transaction, right? Because there's a whole mess of anonymized actors in between. It's kind of the same thing as how onion routing works, where you have an entry node and then a bunch of routing nodes and then an exit node. And the thing is, the entry node is the one that you're always connected to. So they have a very strong incentive to make sure that they retain uptime. Because if they don't, you can just pull out your funds. Before that happens, before that route is actually completed and the final counterparty receives that established path, that process is not atomic. So that process is atomic. So like if any one person doesn't do that interaction, then those funds aren't locked out in general. But once that process is completed, the peer-to-peer payment, which is the actual update in the virtual channel, is completely untouchable, because that can be done in like a Telegram channel. Okay, I could send my friend like a signed state in the Telegram channel, and then they could put that into like on-chain to dispute as well.
I would suggest that you guys still let them kind of layer 2 of the discussion be your turn. Is there any other question?
Hey, awesome panel. One thing that I think didn't come up too much during here, which I always wonder about, is how much of an issue do you think that liquidity and collateral requirements are in a network? And do you think do you think it's an issue? Do you have a solution? Do you not think it's an issue?
I think it's a huge issue. Like the ability to, especially when you talk about multi-hop payments, right? Because in the Nest case, I think it's simpler because usually the hub is just a service provider, right? Like you're basically doing a single hub payment. So in that case, you don't have to route the payment to somewhere counterparty. But in our case, it's like Alice pays ball by this like intermediary, where like this guy has to like also lock up the same like amounts, right? So that's actually a huge issue. And I think our solution is to incentivize this kind of like security provision. So basically by providing liquidity, you're actually like creating value just by like locking up your funds. It's like staking. So we have like we have incentives for like the service providers to like add liquidity to lock money into. I mean, like, in some sense, this is like not worse than the current on-chain situation. Like, you either want your funds, like you can put them in exchange where you can speculate, or you can put them in like hardware wallets where they're kind of like locked up in there, like not able to move. And it's kind of trade-off between the two. And for us, it's like we're trying to incentivize people to lock them up in the channels so they can provide locking services. So yeah, that's a very serious issue that we have to have some like economic models to incentivize that.
Also, borrowing that collateral is stressful. Like the fundamental like part of the security model of channels is like when you're routing over multiple hops, like the intermediaries are staking their own funds. Right? If it's not their money, they can collude to steal it, and there's nothing that can stop you from doing that. Like obviously you could like set up a bond and slash that bond or something like that, but like that is also really difficult. So that's why you can't do like I'm just going to crowdfund money, or like crowdfund these spend those with like a bunch of money that comes from outside investors, like Uniswap or whatever. But yeah.
That's why I like sidechains local contracts.
And just to give one example of that, like for instance, in the hub model, if I want to receive a lot of money, I need to get the hub to front me the collateral in the channel to me under the assumption that I'll be receiving that much. That hub could also be staking that. ETH 2.0, for example, and earning whatever interest rate. So presumably, there's even competition with that, like in terms of making money from having money.
Like the ideal is like when you move to like a network paradigm, and like like I said, we're only a hub right now because we're using it as a bootstrap mechanism actually for that service. But like when you move to a decentralized network paradigm, the goal is like only the outside nodes, right? The ring of nodes are on the outside that serve users are the ones that are actually consistently having to re-collateralize. The inside ones get rebalanced very, very effectively because of the way that routing works. So like routing, it ends up being like very finite. Like you sort of have these different financial incentives. So it's like you can run a routing node which requires minimal on-chain transaction costs and like maximizes your like per transaction back and forth through the automatic balancing. Or you can run a entry or exit node, which is more likely a wallet or POS service, in which case you're already able to charge for other services that you're providing.
Great. Any other questions? So I think that wraps it up. I want to thank the panel again, and please make sure you ask the question after this. Thank you very much.